In this video, I'm going to show you how to do similarity theorem proof. So it is an examinable proof and it is usually for 6 marks in your exam. All you have to do is learn it with understanding, memorize it, and replicate it in your exam. This is the usual layout of the question. It says in the diagram, triangle ABC and triangle DEF are drawn such that angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. Now, if you look at your diagrams, you can see that those angles are marked off as being the same. We've got the circle, the enclosed circle representing angle A and angle D being the same. We've got the open circle showing us that angle B and angle E are the same. And we've got X to represent that angle C and angle F are the same. Okay, the question says, prove the theorem which states that if two triangles are equiangular, then the corresponding sides are in proportion. That is, AB over DE is equal to AC over DF. Now, they mentioned that these two triangles are equiangular. We understand that the word equiangular means that all of the corner angles in these two triangles are equal to each other. So, like what they've mentioned above here, angle D is equal to angle A, angle B is equal to angle E, angle C is equal to angle F. Now, since you're going to have one of two proofs that can be tested in your exam, the first being the proportionality theorem proof, if you're not sure how to do that, I have posted a video on it, so you can check that out. And the second proof being the similarity theorem proof. So how we identify this as being the similarity theorem proof is we notice that we're given two separate triangles. So that immediately tells you that we are comparing these two triangles, so we need to show that they are similar. Now, the first thing we're going to do is mention our construction. So our construction for this proof comes in two separate parts. The first part is, on the bigger triangle ABC, we are going to draw a line from one end of the triangle to the other in such a way that the line that we draw needs to be more or less the same length as this line EF. So let's label this, let's call it PQ. And since we are trying to draw this line so that it's the same size as EF, what we're actually trying to show is that triangle APQ is the same size as triangle DEF. So part of our construction, we are going to draw line PQ. So let's mention that. Like I said to you, there are two parts to this construction. So let's say draw PQ. And you can call it any other name if you'd like. And the next thing we need to show is that AP is equal to DE. So on these two triangles, we are going to mark off AP and DE as being equal to each other. And also AQ and DF need to be equal. So we're going to mark those as well. Now we need to mention that in our construction. So we're going to say on AB, mark off AP equal to DE. And on AC, we marked off AQ equal to DF. So ultimately what we're trying to show here is that this smaller triangle that is now created, triangle APQ, we're trying to show that it is the same as triangle DEF. But remember that we cannot just assume these things, okay? If we are trying to show for sure that they are equal to each other, then one way of proving that two triangles are exactly the same is by proving congruency. So that is going to be our second step towards proving these triangles similar. We are going to prove congruency for triangle APQ and DEF. So let's say in triangle APQ and triangle DEF. Now remember, congruency requires three reasons. So we need to have three separate reasons that are contributing towards having these two triangles being congruent. Now, if you look at your two triangles, the first thing you notice that are the same about each other is AP is equal to DE. So let's mention that. AP is equal to DE. Now, firstly, we know that it is a side, and where exactly do we get this from? We get this from our construction. That is something that we filled onto our diagram. So we can say side, and we can say construction. The second thing we notice that is the same about these two triangles is we've got angle A equal to angle D, and that was actually given to us in the information provided. So we're going to say angle A is equal to angle D. Now that is an angle, and that was given. And the third thing that we notice is the same about these two triangles is side AQ is equal to DF. Again, that comes from our construction. So we're going to say AQ is equal to DF. That is a side, and that comes from our construction. Now, since we have these three valid reasons, we can conclude and say that therefore, triangle, this is going to be APQ, is congruent, and remember, congruency are three horizontal lines. It's congruent to triangle DEF. And our reason that we've used here is side, angle, side. Now, if you go back to these triangles, since we've proven that these two triangles are congruent, meaning that they are exactly the same, so their corner angles should be the same as well, where we already know that angle A is equal to angle D. So here, angle P, or rather this portion, let's call it angle APQ, should be the same as angle E. So we can actually represent that. There's APQ is the same as angle E, and angle AQP should be the same as angle F. So AQP should be X as well. Now, the next thing that you need to notice is that because you've proven these two triangles to be congruent, you should notice that on your big triangle, you can have corresponding angles being equal to each other. If you look at the left-hand side, we've got angle B and angle APQ. And if I just had to draw it separately to show you, here we've got this F shape. And from fun X with parallel lines, we know that corresponding angles are equal to each other. So by showing that these two angles are equal, it actually proves that the line PQ and the line BC should be equal to each other. And if that is not enough proof for you, there is the right-hand side, which you could also look at. And focusing on the right-hand side, you've got angle C being equal to angle AQP. And if I just had to draw that separately to show you, that also forms an F shape where we have corresponding angles equal, which should mean that line PQ is parallel to line BC. So based on these corresponding angles that we have, we can immediately mention that line PQ and line BC are parallel to each other. So that is going to be the next thing that we do. We're going to say, therefore, PQ is parallel to BC. And our reason for saying this is the corresponding angles that we have noticed. So you can write out the whole reason if you'd like. Corresponding angles are equal, but this should suffice. Now that we've proven that these two lines are parallel, there's something that you notice about this big triangle. It is very similar to our proportionality theorem triangle. So based on what we have, we've got PQ being parallel to BC, so we can actually write out the sides that are in proportion with each other. And we're also trying to write it out in a way that is going to get us to this answer that they want. Let's focus on the left-hand side. So the answer that they are looking for has AB in the numerator, which is the entire length. So we are going to take AB over the shorter side, AP. And on the right-hand side, we are going to take AC over the shorter side, AQ. So let's mention that as a starting point. We are going to say AB over AP is equal to AC over AQ. And your reason here is that it's not exactly the proportionality theorem that we're trying to prove, it's the similarity theorem. So as our reason here, let's write out the line parallel to one side of the triangle. So basically, that is the definition of the proportionality theorem. It says that if we have a line that is parallel to one side of the triangle, it divides the triangle proportionally. Alternatively, you can just mention proportionality theorem, but from what I have noticed, this is the preferred reason for this step. Now, at the same time, we notice that we have in our construction mentioned that AP is equal to DE, and we have also mentioned that AQ is equal to DF. So all we have to do now is, in these denominators, we are going to replace AP with DE, and we are also going to replace AC with DF. And this ends up giving us the exact fractions that they wanted. Okay, so if we just scroll back up, we've got AB over DE equals to AC over DF. So just remember that when it comes to the similarity theorem proof, there are three main parts to this proof. The first being your construction, where you start off by drawing a line in the big triangle that is more or less the same size as EF, the bottom of the small triangle. At the same time, you mark off that left-hand side as being the same as the left-hand side of the small triangle, and the right-hand side here, AQ, as being the same as the right-hand side of the small triangle. The next step is for us to prove congruency. So we prove that triangle APQ and DEF are exactly the same. Once we've proved congruency, that allows you to prove that PQ is parallel to BC. So that was your second step. Your third step is you are going to make use of the proportionality theorem in your big triangle to show that the sides are in proportion. And all you have to do from there is replace the denominator or the denominators with what they are equal to. Here, AP was equal to DE and AQ was equal to DF. So that is your similarity theorem proof.